Now go back to this and insert page after. So much of what we do here is based on the calculator, and we can't take the calculators home. And I know this won't help everybody, but if you have an Android phone, there is a emulator that you can get for free. It's called Wabbit. Why is that not going? Try this again. This thing doesn't want to cooperate. Go, go, go. Okay. Okay, let's try this again. Wabbit. EMU. I think, I've only recently gotten a cell phone, so I don't understand half this stuff. But I guess if you go to the Play Store and do a search for this, Wabbit EMU. EMU stands for emulator. Emulator is what that is, right? It's not the calculator. It emulates the calculator. So that Wabbit EMU is a calculator emulator. So if you are interested in that, and leave it at that. So the first one we're going to go to here is go to number 12. And some of this stuff, more so than in past years, including last year, we've kind of already done this. But if you don't remember what we did, this is your chance to let's not only know it, but write down how it is we solve something like this. Right? Identify all of these which are equal to I. Right? I to the 47th, I to the 33rd, I to the 21st, I to the 15th. How do you do those in the calculator? Where do you find the I? Second decimal point, right? Okay, so if I put in the calculator, I think this thing is choking or something. Here we go. Clear. If I put in the calculator for the first one, I to the 47th, right? Second decimal point raised to the 47th. I get this kind of confusing thing. How do I do it so that it doesn't give me all this e to the negative 13th stuff? Go, say again? Yeah, you go to the math, arrow over to the num, and it used the number 3. Math, num 3, right? And now put in I to the 47th. Second, I cat 47. End parenthesis, just like that. And then when I hit it, it just says negative I. It doesn't include all this stuff here, which is really 0. Calculator not rounding to 0. Okay, so remember that. And which ones did you say were equal to positive I? Not negative I, positive I. You said I to the 33? Okay, this one. Which other one? There's one other. Which one? And I to the 21st. Both of those should have given you a positive I. Right? What did you get when you did I to the 47th and I to the 15th? I to the negative I, right? So, and then again, this would be one of those technology enhanced, right? That it's giving you the directions. Click on the box that you want. So you don't go to the first one that equals that, right? You got to do them all and then click on all of them that are equal to I. My bet is, as we're going through these 50 questions here, and that when you get that kind of question on the test, you're going to get it right. That's one in the right column right there. Okay. Remember, we need 27 out of 50, 54%. So there's one. Everybody agree you can get that one? Okay. Go back to number 2. Okay. If you get operations with imaginary numbers like this, then really the only thing you need to know is where are you going to find the I? And we already did that, right? The I is on the decimal point. So if you enter this in exactly as it's written here, the calculator will do all the simplifying, right? It'll take into account parentheses and minus signs in front of parentheses. Just make sure you enter it exactly like you see it, right? So let's try that. Minus 11 plus 13. So when it looks exactly like it, you hit enter and you got, everybody get that? Negative 17 minus 9i. Good to go? Everybody, right? Don't sit on your hands. So that was letter A. Okay, another, if you get that on the test, I got to think you're getting that one right. Right, there's 2. Okay, this is number 1. Right, now, if we're going to do this with math, right, we're going to do this by finding a common denominator, multiplying each fraction by exactly, what you need to make the common denominator, and then you add the numerators. If you're going to do this for the strategy, you're going to store a value for the variable, and then you're going to see what that decimal, what does that equal as a decimal, and then see what all of those equal, right? So we've got one variable here, and it's n. What do we recommend you store for a variable? If you just have one, use pi, right? Pi will make it easier. Then we're all on the same page, right? We're not guessing, will I use 5 this time or 7 or no, just use pi for one variable. All right, so store n equals pi, right? And how do you do that in the calculator? How do I make the calculator think that n equals, right? You're going to go, first you bring up the pi, second, pi is on the hat, and then you hit store, S-T-O, so it looks like a right arrow. And now you can use, if you're going to use n, then you're going to have to go, n is above the log right there, so alpha n. So when you hit enter, now it understands n equals 3.14159, all of that pi. Okay, now, so let's see, store n equals pi. Pi, so n. Right, how do we enter things in the calculator as a fraction? Yeah, so we're going to use alpha y equals, alpha, that's wrong, alpha, clear. And then the very first one, right, 1, numerator over denominator, it brings up the fraction form. That will save you so many times, that otherwise you would have had to use parentheses, right? And if you forgot the parentheses or if you didn't put them in the right place, then you're going to get it wrong. But now we can do this. Just put in this 3n, 3 alpha, and arrow down to the denominator, alpha n plus 3, right? Arrow to get over there, plus. Now bring up another fraction, alpha y equals 1, and 5 divided by n minus 4. Alpha n minus 4. When I hit enter, it's going to turn all that into a decimal, negative 4.29, let's say. So this one equals negative 4.29. Okay, put these in until you find one which has the same decimal value. Remember, bring it up in the fraction format and then just enter it in exactly like you see it there. If they've got parentheses, you need parentheses. I got at least one that thinks he knows the answer. Yes. Okay. Go to the dean. Go to the dean and boys. Anybody get an answer? Was it A? What was the value of A? Say again. What did you get when you did this one? Negative 2.01. So that's not it. Okay, and then this one you got the negative 4.29, right? Dot, 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 dot. So the answer is B. So again, I mean, the concept here is this is the same as this for all values of n. So of course it would have to be true for one value of n, right? If it's true for all, it's got to be true for one. We just showed that it's equal for that one value, so that has to be it. Now, I'd say that the most missed questions on the SOL are rational and radical. And when it comes to the rational, as you can see, when you get it in this format, you're probably going to get them right. Okay. Right. Same thing, do the same thing with this one here. Again, I encourage you to be writing yourself notes next to these problems. You're going to use this as your preparation for our test. As long as you know how to do this stuff, it's going to be easy. Right, this is, nobody likes to factor difference of cubes. But you know, in a way, you don't have to, do you? Just store a value for x and see what this equals. I'm getting negative 184.999. So which one of these has the same value? one thing I could say is because if I know a little bit of the math, right, the difference of cubes has a formula. A to the third minus b to the third is a minus b times a squared plus ab plus b squared, meaning that it's got to be a binomial times a trinomial. It has to be. So the first two answers cannot be it. It doesn't have the right number of terms in each set of parentheses. So there's no point checking this one and this one. It has to be one of the second two. Which one is it? It's the D, right? Because the decimal is the correct decimal, right? And now, if you look at the formula would have said, in our problem here, the X was the A, and the cube root of 216 is 6, right? So that should have been X minus 6 times X squared plus 6X plus 36. Right? They had like it was 2 times A times B, but that's not in the formula. But in any case, you're using the math to actually eliminate these two choices. Don't even try them; they're not going to work. And then you use, the store of value strategy. So far, what have we done? 5? Yeah. It has to be a binomial times a trinomial. 2 terms times 3 terms, right? This one is just 1 term cubed. That can't be it. This is 2 terms times 2 terms. That can't be it. Okay, both of these are 2 terms times 3 terms. So they both could be it. So you check those two. Piece of cake? Right. Okay, do the same thing with this one. This is a simplify a rational expression. And really everything you need to do this problem, we've already covered, right? You know how to store a value for R. Or if you want to just use X, right? X is a lot easier than having to do alpha R every time. You know how to enter in the fraction form. So good to go. I'm going to do it. Alpha y equals 1. X squared minus 6. So I'm getting that it should be 4.503 you're looking for. Anybody get an answer? Internet? It was letter A. It's correct. It's letter A. I mean, honestly, this one, if we were doing the math on it, this is a fairly simple factoring problem. That should have been R minus 3 times R plus 2. And then you cancel the common factors, so all that's left was R plus 2 over R minus 2. Again, another one I know you can get right. We're up to 6, I think. 6 for 6, right? Only need 27. Now this one, you don't even have to store, this is number 7, you don't even have to store a value, right? Because there are no variables. Just put it in the calculator, see what the decimal value is of this, and then see what the decimal values are of those. if you don't do it that way, that's a FOIL, right? You just have to multiply everything in the first set of parentheses times everything in the second. Remember, what is the square root of 7 times the square root of 7? 7. Right? It's like saying, what's the square root of 7? Squared, right? You square a square root, they cancel each other out. And then when you make these middle terms, 6 root 7 plus 5 root 7, remember, those are like radicals because they're the same kind of root, right? Square roots, and they have the same number inside, same radicand. So how do you add like radicals? You add the coefficients. So did you all get D? Right. You had the decimal values like 66.103, and you went through these, and you finally got down to the last one, and it was D. Okay. So far, so good, right? I think that's the last of these for now. Now we're going to go to the lesson part of it, which is actually reviewing the math that we've done for a different content area. And this is on the chapter on radicals, and we're just touching on a few parts of this, not everything, but just a few parts of it. The first is properties of exponents. There's always going to be one problem, which is something about properties of exponents. Okay, so remember, if you're multiplying, right, x squared times x to the fourth, since the x's are the same base, then what do you do with the exponents to simplify that? You add the exponents, right? So that is x to the 2 plus 4, which is x to the 6. And that is this property right there. Right, the homework I give will all be based on this stuff, right? These lesson slides. All right, the next property. What do you do if you're dividing? Subtract the exponents, right? So that is x to the 4 minus 2, which is x squared. Right? Second property of exponents. Okay, since this is a divide, and we just said, what do you do when you divide? You subtract the exponents, right? Well, that would be x to the 4 minus 4, which is x to the 0, right? But what is anything divided by itself? 1, right? So, in fact, anything raised to the 0 power equals 1, right? It's not that thing raised to the 1, it's the number 1. Anything to the 0 power equals 1, except for 0. So that's a third property of exponents. And if I was going to do the divide on this one, right, to subtract the exponents, x to the 2 minus 4, which is x to the negative 2, how do we get rid of the negative exponent, since we're always told use positive exponents? Yeah, you flip it. A to the negative n is 1 over a to the positive n. So if you got a negative 2 there, then you're going to write it as 1 over x to the positive 2. Just like if I have 1 over x to the negative 3, then I would flip it, and it would be positive 3 in the numerator. And so that's how we deal with negative exponents. Right? How is it that if you raise a power to a power, what is the operation between those two powers? It's a multiply, right? Remember, it's an add if it's x squared times x to the fourth, but if it's x squared to the fourth, that's a multiply. So that is x to the eighth, right? And it wouldn't matter if it was x squared to the fourth or x to the fourth squared, it's still x to the eighth. That's this property right here. So when you raise a power to a power, multiply. And then the last two, if you have an exponent outside parentheses, and there's more than one factor inside the parentheses, you could think of it like distributive, right? You're going to bring that n in as a power on everything inside, right? If I take this 2x in parentheses squared, that would look like 2 squared times x squared, which is 4x squared. Definitely, you could just think of it like a distributive. I think I did this one just to show you that if I did 2 times 4 in parentheses squared and use this property, that would be 2 squared times 4 squared, which is 4 times 16, which is 64. Or if instead I would have just simplified this before I started, that's 8 squared, which is 64. So parentheses, if you have a power outside parentheses, you can distribute it to everything inside. And that's true even if it's a divide that's inside. You're still going to bring it inside like 8 squared over 4 squared. Right? Just distribute it to everything inside the parentheses. 64 over 16, which is 4. If I would have simplified it first, I would have 8 over 4 is 2. 2 squared is 4. Okay. So that's a review of properties of exponents. Right. And the reason that we need to do these first. Just some practice doing this. There's like 3 problems in the homework where you're going to be doing a similar kind of thing. Okay, so if I'm going to multiply these together, the 5 times negative 3 is negative 15. And then how do you simplify a to the 3rd times a to the negative 4th? What do you do with the exponents? You add them, right? That is add a to the negative 1. Okay, we don't want to have a negative exponent. How do I get rid of the negative exponent? Flip. What do I flip? Just the a, right? Don't flip the 15 or the negative 15. It's only the thing that has a negative exponent that gets flipped. And I don't need to write the 1, right? Okay, what did we say we would do with the power outside parentheses? Distribute it, right? So that is negative 4 squared, x to the negative 3 squared, y to the 5th squared. Okay, negative 4 squared you can work out, right? What is negative 4 squared? Positive 16, right? Don't remember, if you put that in your calculator, negative 4 without parentheses squared is going to give you negative 16. So don't mess that up. 16. And now, what do you do when you raise a power to a power? What's the operation? Multiply. X to the negative 6. Y to the 5th squared is 10. And then I got one last thing. What do I have to do? You got to flip the x to the negative 6, right? Because you can't have a negative exponent. So it's 16 y to the 10th over x to the 6th, positive exponent. And finally, so there's only, this has got a coefficient of 1, and there's a 4 in the numerator, so 4 over 1, 4. That's not going to simplify at all. Okay, we've got a to the 1st over a to the 5th. Yeah, it will be. We'll use the subtraction rule and just say 1 minus 5 is negative 4. And 6 minus 1 is 5. And 3 minus 3 is 0. Okay, so that is 4b to the 5th over a to the 4th. What happened to the c? Because it's to the 0 power, it equals 1. So it's done. Or, just like if you instead just thought, oh, look, I'm just going to cancel those, that's fine, right? That is the same thing. So you cancel those. And if you think, normally when I was your age learning this stuff, we would have never written this as a to the negative 4th. You would have just recognized that the higher power is in the denominator, so you just do 5 minus 1 and put the answer there directly, right? I'm not sure if you see that easily or not. Okay, So remember, the reason that we do the properties of exponents is we learn in this chapter that we can represent radicals as things raised to fractions for powers and exponents. So we need to know the properties as we simplify these things. But at the very beginning, these are just the basic concepts, right? The basic concept is if 5 squared is 25, then the square root of 25 is 5. Or it could be negative 5 if you're being technical about it, right? Because negative 5 times negative 5 is 25. Normally, if they give you a square root, though, you assume they mean the positive. You would assume it's a positive 5 only. Now, if the square root of negative 25 is not a real number. I mean, that would be like the square root of negative 1 times the square root of 25. And what is the square root of negative 1? I. Remember, that's the definition of I. It's imaginary. So this is non-real. And generally, when you do this kind of stuff, at that point, you just stop and say you can't do it. Now, if you use, that's because it's an even power. If it's an odd power, 4 to the third is 64, which means the cubed root of 64 is 4. Could it also be negative 4? No, right? Because the cubed root of negative 64 is negative 4. So negative 4 times negative 4 times negative 4, right? The first two multiply together to give you a positive, and then you do it one more time and it's the negative. So actually, this one is real. It's just negative. Okay. So that's the basics of that. What would we say is the cube root of negative 8? Okay, the cube root of 8 is 2, and the cube root, an odd root of a negative number is negative. Now, you can do that in the calculator, right? You remember where to go to do cube roots, any root in the calculator? Right, math 4 or math 5. Okay, and what about the fourth root of negative 1? Try it. How do you do the fourth root? Okay, 4, math 5, negative 1, what did you get? It's a non-real number. Any even root of a negative number can't do, right? Because every time you multiply them together twice, you get a positive. So how do you get a negative out of that? So this is non-real because that is even, right? A negative number, or an odd root of a negative, that's fine. That is a negative. Now, when we simplify radical expressions, the square root of x squared is x. The cube root of x to the third is x. The fourth root of x to the fourth is x. I mean, those are like inverse operations. They undo each other. All right. If you take the square root of x to the third, that does not undo it, right? There's some simplifying to do. Generally, the way I look at it is like this. If I look, there's an index here, which is usually not written, which is 2. You say 3 divided by 2. Does that go evenly? No. So you're going to break up this x to the third into the most x's that could be simplified. And that, in this case, it would be x squared. And what would be left is x, right? That's properties of exponents. X squared times x is x to the third. And now take the square root of both of those. And the square root of x squared, as we said, is x. Right? How about this one? Is 5 divided by 3, does that go evenly? No. So how could I split up x to the fifth so I get the most simplification? X to the third times x squared, right? Properties of exponents. 3 plus 2 is 5. And now you take the cube root of both of them. Right, so that is x times the third root of x squared. And how about this one? How am I going to split it up? X to the fourth, x to the third. Fourth root. So that is x times the fourth root of x to the third. Okay, now it gets more complicated when you get something like this, right? We're going to have to deal with the number, and we're going to have to deal with the variable inside. Is 49 a perfect square? Yeah, so we don't have to do anything with that. That'll go. How about the x to the fifth? Will we be able to take out all the x's? No, because it's a square root. 5 divided by 2 doesn't go. How could I break it up into the most x's that I could simplify? X to the fourth times x, right? I mean, that, because I can simplify an x to the fourth, and that'll only leave one x inside. That's good. So this is how I'm going to rewrite this. So it'll be the square root of 49 times the square root of x to the fourth times the square root of x. And the square root of 49 is 7, we assume positive. The square root of x to the fourth, how many x's come out? 2, right? You divide 4 by 2, and you get x squared. And then the square root of x, can't simplify. Okay, how about the third root of 125 x to the ninth y to the fourth? Is 125 a perfect cube? Okay, remember when we did this stuff in class, they gave you a sheet with all the perfect squares and perfect cubes. Obviously, you're not going to have that when you take the SOL, right? But how could you make yourself a table of the perfect squares and perfect cubes on your own using the calculator? Go to y equals, clear. And on the first line, I'm going to put x squared. And on the next line, enter, I'm going to put x to the third. And enter. Now I'm going to go to the table of values, right? Where's the table? Second graph. And depends where you have it started, but. So there's the value, and then here's the perfect squares, and here's the perfect cube. So is 125 a perfect cube? Yes. What number cubed equals 125? 5, right? So actually, this part of it will simplify easily. And then, will we be able to take out all the x's? 9 divided by 3, does it go evenly? Yeah, so we don't need to split that up. How about the y to the fourth? No. So let's make this the third root of 125 times the third root of x to the ninth times the third root of y to the third times the third root of y. Right, the only one I had to split up was the y's. The third root of 125 is 5. Right? The third root of x to the ninth, how many x's come out of that? 3. 9 divided by 3 is 3. And how many, the third root of y to the third is y. And then the only thing left in the radical is the third root of y. So that's the basics of how do you simplify radicals. Again, we're reviewing the math. A fair number of these problems, as we'll see, you'll probably be able to use our strategy of storing a letter, a value for a letter, and it'll work that way. The only thing is you might have 2 variables. What do we store for the second variable? We use pi for the first one. What do you use for the second if you had to? E, right? E is the base of a natural logarithm. It's right below the pi on the calculator. There's the E. Okay, and let's skip over that. Okay, product property. The product property with radicals means that if you have a product of radicals, you can multiply them together into one radical. So the square root of 2 and the square root of 8, neither one of those simplifies, right? But if I put them together into one radical, the square root of 2 times 8, that's the square root of 16. And that simplifies. So sometimes by putting them together, it actually makes it easier to simplify. How would this one simplify? I mean, again, multiply them together. The third root of 2 times 32. which is the third root of 64, which is, again, go to your perfect cubes, right, in the y2 column. The 64 is a perfect cube, and the number is 4. So we'll do one of these anyways. So we're going to multiply these two together. Now, what are we going to do with the numbers 3 and 2, which are coefficients of the radicals? We know what we're going to do with the radicals, I hope, but what are we going to do with the 3 and the 2? Just multiply them together, right, to stay outside. Right, so this will be 6 times, and now put everything together inside. That's 3, the third root of 5 times 50 is 250. Y to the third times y to the fourth. What? Add them up. Y to the seventh. Right. Okay, now, the third root of 250. Is 250 one of our perfect cubes? Let's see, we go from 125 to 216 to 343. It skipped right over 250. 250 is not a perfect cube. Does it have any factors which are perfect cubes? All right, go to the first number less than 250 and divide. What's 250 divided by 216? Does it go evenly? How about 250 divided by 125? It does. It's 2 times that. So you can break up that 250 into one factor, which is simplifiable, and one that's not. So this is going to be 6 times the third root of 125 times the third root of 2. Okay, and what about the y to the 7th? Will we be able to take out all the y's? See, 7 divided by 3 does not go. How could I break it up into the most y's that could be simplified? Y to the 6th and y to the 1st, right? So that is the third root of y to the 6th and the third root of y. And now just go down each one and simplify. This is 6 times the third root of 125 is, right? It's in your table. 5, right? So times 5. The third root of 2. The third root of y to the 6th. How many y's come out of that? 2. 6 divided by 3 is 2. And the third root of y we cannot simplify. So now put everything together which is inside the radical and everything together which is outside the radical. So that's 6 times 5 times y squared. 30y squared. And the third root of 2y. Okay. Now, we also have a quotient property, right? Just like we have the product property for multiplication, you have a quotient property for division, which means if you have a division of radicals, you can put them into one radical if it looks like it will help, right? So in this case, it does. The square root of 32 over the square root of 2, 32 over 2 is 16. So the square root of 16 is 4. That can be simplified, right? How about if I put these together here? What would it look like? It would look like the third root of x to the 4th divided by x. And what is x to the 4th over x? It's x to the 3rd. I mean, subtract 4 minus 1, properties of exponents. So that is the third root of x to the 3rd, which is x. Done. Okay, so this one, I mean, normally it should look like if you put them together into one, it is going to simplify. So there's no a radical in the denominator anymore. That's always the key. No radical in the denominator. This one, as you look at it, it's got a 50 in the numerator and a 2 in the denominator. Does 2 divide into 50? Yeah, so it's going to work for us if we put these together into one. And the x to the 6th over the x to the 4th, you know, that'll leave an x squared in the numerator. So normally, that's what these kinds of problems look like. this would be the square root of 50 x to the 6th divided by 2x squared, which is the square root of 25 x to the 4th. Okay, the square root of 25 is 5. And the square root of x to the 4th, do we need to do anything to simplify this? 4 divided by 2, they're all coming out. How many come out? 2. So that's 5x squared. That is simplify, multiply, divide. And then the last is, again, the reason we do properties of exponents here is because you can write a radical, like the square root of 4, as 4 raised to an exponent, which is a fraction, 4 to the 1/2. Right? The third root of 27 is 27 to the 1/3. You kids? Now, the thing that we're asked to do on the SOL, more than anything in this section, is just you should be able to convert it from the radical notation to the rational exponent notation. So this is the pattern right here, right? If you look at, here's the radical, it has an index, square root is 2, cube root is 3, etc. And then here is raised to a rational exponent. The index is the denominator, the power is the numerator. Right? So if I was going to convert this one, 8 to the 2/3, to a radical, right, it should be that the index is the denominator and the power that it's being raised is the numerator. Or you could do it, you could put that power inside or you could put it outside. It doesn't make any difference to the problem. That's what this is showing right here. Right? So that's the pattern. Remember, the index is the denominator. The power is the numerator. So how would I do this x to the 3/7 as a radical? What would be the index? What number goes here? The 7 goes there. Okay, so which leaves x to the 3rd in there. All right, this y to the negative 3.5. First, how do we get rid of the negative exponent? Flip it, right? So that's 1 over y to the 3.5. And then what fraction does 3.5 equal? Put it in your calculator. How do you turn that decimal into a fraction? It's 7/2. Okay. So that is 1 over y to the 7/2. And that, what is the index? 2, but we usually don't write it 2, so that leaves y to the 7th. It's raining. I don't think it's pouring, but in these trailers, it sounds like it's pouring. Okay, convert these radicals to rational exponent. What is this one going to look like? Right, it's going to be a raised to a fraction as a power. What is the denominator of the fraction? 2, because this has got a little invisible 2, so that's 2. And then what's in the numerator? 5. And then how about this one? This is b to the 3/5. Right. So the homework is a little bit of properties of exponents, a little bit of just simplify a square root of a number, and where the only thing you're really looking at is it real or non-real, basically. And then we're going to, these are the simplify a radical, multiply radicals, and divide a radical, one problem. And then these 4 are just converting from exponential to rational. Should not take you that much to do that. I think, you know, if there's any challenge here, it's probably these and a little bit these. These are going to go really quickly.